And now a bit another example for people who haven't got bored yet. We have a more specific example here. So here, again, we are assuming that the mean is 90. And we have this hypothesis test where we are just, as the alternative hypothesis, assuming that mean does not equal to 90. And we're doing this test with 95% confidence, aka our alpha is 0.05. And here you can see that our standard deviation equals of the data equals 20. So if we are now calculating the standard deviation of the sampling distribution, and the standard error, some call it. So basically, the standard deviation, if we would take multiple different samples, what the standard deviation of the means of those samples would be. So this is very deeply related to central limit theorem. And we get that the standard deviation would be 2.0 in this case. With this assumption of this data set and this standard deviation and then this standard deviation of the sampling distribution or standard error, we can build the distribution like that. So this is all the different sample means we would be able to get if the null hypothesis is true. So the center, as you can see, is 90 here, and there is certain deviation of the data. And if we scroll down here, you can see that as we are performing this null hypothesis test, we are then cutting these rejection regions based on the alpha. Alpha equals 0.05 divided by 2. So if this data should fall under this category, we are assuming that this data or the sample mean does not fall under this null hypothesis distribution. Okay, so now here we again are reiterating over this 90 versus 94 example, where if those two distributions would be close to each other, we have the situation where actually quite often taking the data from the alternative distribution, we would be hitting the area within the non-rejection region for null hypothesis, which means we would not be rejecting the null hypothesis, which with although the null hypothesis actually is false, because we are in this right now in this case where actually we are taking the data from like the distribution where the sample mean or the mean is 94. And now here again, there is this alternative situation where the alternative hypothesis mean is 98. And here you can see that the power, which we derived earlier, is much bigger because the differences between those means is much higher. Okay, so now we come up finally to this formula that consists of three important aspects. So it's the set value for 1 minus alpha divided by 2. So this is what we get from the just building up the confidence interval or building up the hypothesis test, 95 or 99% in this case for it's 1.96 is the set value. And then we use another set value, and this is based on the power. And this is based on this one-tailed power that we want to make sure that the alternative distribution uses to classify as as means that are not so regular, basically. So if alpha divided by 2 is here, then this 80% or this Z1 minus beta is here. And then we have the effect size, which I also talked about earlier. And then we get this N. And basically this N allows us to build this significant enough sample to detect that specific effect size, or that specific difference between the two data sets. So I think it's very important for you as well now to go over these examples to get a concrete example of what I have been trying to explain here. Because the theory is still theory, and you need practice to really understand the point here.